This is Thursday's lesson, Squares of Binomials. This will be the first day of 2 days on this section. And it is from page 209 is really where we're going to start at here. We're talking about perfect squares and what is a perfect square. And there's a few steps to figure out what it is and whether or not what you're looking at is considered a perfect square or not. So let's start off. Take a look at example 2, page 209. And this is A. The trinomial that you're working with is 4x squared minus 20x plus 25. Now I'll go ahead and start off by saying this is a perfect square, and now I'll tell you how to determine that. Let's look up here at the checklist. It says what is a perfect square. Number one is the first term a square. So when you look at the very first term, you're talking about 4x squared. So that is a square. That is 2x to the second power. So you can answer yes to that question. Secondly, is the last term a square? So let's look at that last term. It's 25. Well, obviously that is 5 to the second power, so far so good. We got 2 out of 3. Now here is the deciding factor. Is the middle term twice the product of the factors of the first and last terms? And that's where it gets a little complicated. Here are your factors. The factors are 2x and 5. That's what it means by the product of the factors of the first and last terms. So to determine if this is considered a perfect square, you've got to take twice the product, 2 times 2x times 5. So multiply 2x times 5 and you get 10x. And when you take 2 times that, then you are going to get 20x. And you notice that you ignore the signs. This is a negative 20x. We're not interested in that being a negative sign. We're just interested in taking 2 times 5 and doubling that to get negative 20x. Now look at example B. So yes, this is a perfect square. So I forgot to answer the question. On B, that example is 64u to the second power. The middle term is 72uv, and that middle term is going to be what determines every one of these. And your last term is 81v to the second power. So now when you look at the first term being a square, it is a square. It is 8u. The square root of 64u to the second power is 8u. So that is a square. Your last term, question 2, is also a square, and that's 9v is the square root of that. So 9v squared. Now this is not a perfect square because what you're going to do is multiply 8u times 9v and then double that to see if that equals your middle term. And it doesn't. 8u times 9v is 72uv. In order for this to be a perfect square, this would have had to been doubled to 144. So 144uv as a middle term gives you a perfect square. But since it was 72uv, then this example is not a perfect square. So that's how you determine that. So let's take a look at a couple of the problems. Let me clear all this off. We're doing 1 through 31 odds today. I want you to be able to check your work. Be sure you're checking your work when it comes to this. So number 1, write each square as a trinomial. Now this is going to look fairly simple, so we'll fly through this one. You've got n plus 5 to the second power. Now this is called a perfect square. Where we have been working with difference of two squares, where you had 1 plus and 1 minus binomial, but the first and last terms were the same, now it's going to be the exact same binomial repeated, n plus 5 times n plus 5. Now when you work this out, you have n times n as your first term, so that's not going to look any different to you. Then you have n times a positive 5, which is a positive 5n. Then you go back to your positive 5 times n, which is another 5n. So that's why you doubled it to test for a perfect square. And then 5 times 5 gives you 25. So what you're going to have is a repetition on every single one that works like this a repetition in the middle term, you're going to see it twice. So 5n and 5n gives you 10n, and then your first term will be n squared, and your second term will be 25, or your last term would be 25. So when you fit that back into the test, this is a perfect square, this is a perfect square. And to figure out if the middle term fits, you're going to take number 1 times 5, and you're going to double that. So 5 times 2 is 10, so there's your perfect square. So it's n squared plus 10n plus 25. You don't need the 1 there. Let's go to something a little more challenging. And we're not going to do a whole lot. I think you'll have a pretty good time with this. But let's look at number 27, be the last one we do. 27 is 4x squared plus 9 plus 12x. So you have a couple of challenges here. The first thing, anytime that you don't have things written in order, rewrite it in the proper order. You want your highest degree term first, which is 4x squared. And then you want your next degree, which is 12x plus 9. So when you're doing quadratic trinomials, which is what you're going to do and live, eat, and breathe for the next month, this is the order you want it in. X squareds, then x's, then 9's. Now that that's written in order, you're trying to determine the number 27 to decide whether it's a perfect square. If it is, you're going to factor it. Now, a perfect square, you're going to factor into two binomials. Let's look at the 4x first. 4x will be determined from multiplying your first terms together. The square root of 4x squared is 2x. So that means the square of 2x is 4x squared. So squares and square roots are just opposites. The square root of 9 is 3. 3 times 3 is 9. So let's throw our pluses in there. It has to be pluses for the middle term to be a positive and the last term to be a positive. Both have to be pluses. You can have any negatives in there. Now let's see if this works out. Your two middle terms, I'm going to show this in a little different way. Two middle terms will be 6x and 6x, both of which are positive. When you put those together, you will get the 12x that you have in the middle. So yes, it is a perfect square. And the way you show that is 2x plus 3, and put your exponent up there as a squared. So this is actually your factored answer for that one. This isn't wrong, it's just not as simple and neat as this particular answer version is. Now you can work that out the FOIL method, first times first, do your outers, then do your inners, and then do your last. But as you become faster and more proficient at it, this method is much easier to determine that middle term. So a lot of times before you do any kind of test on whether it's a perfect square, it's easier just to try to factor it and see if your answer does actually fit the problem at hand. Don't forget to reorder. You have more than one that's going to be like that. And in that problem set of 1 through 31, odds, you only have, looks like I only can see one that will not be a perfect square. So all but one should factor out. So good luck with those.